Okay, hi, I'm Bridget Kromhout. Unlike everyone else, I'm going to stand next to the lectern and not behind it, because when you're this short, it's like, no. Hi. Thank you so much for the introduction, Chris. And like he said, I do other things than DramaFever, though I'm going to talk to you today about DramaFever's technology. But you can definitely catch up with me either on Arrested DevOps or go to a DevOps Days event. I have to put in a plug for, we have the CFP for DevOps Days Minneapolis, closes tomorrow. So if you have a hankering to come to Minnesota during the 1 month of the year, it has never in recorded history snowed, you could come in July. Yeah, you can, and yeah, if you check out arresteddevops.com, you can see the podcast that I co-host. We had, for container-related stuff, we had James Turnbull, formerly of Docker, on talking containers, Docker, et cetera, a couple of episodes ago. So you may find that interesting. And yeah. I work at DramaFever.com, and we are a streaming video site. We've been around since 2009. We've been running Docker in production since October 2013, which I'm pretty sure the main thing on the Docker website at that point, correct me if I'm wrong, Team Docker, but I think the main thing on the website on that point was like, under no circumstances should you run this in production, which apparently led my boss, Tim Gross, to think, we should run this in production. Which actually, I think was probably a good move, because I joined in July 2014, and I'm not going to lie, one of the things that makes a place kind of exciting to work is it's July 2014, and they're running Docker in production. They're not afraid of things. Excellent, let's try. So it's a good recruiting tool. And the site itself, the DramaFever site specifically, is a streaming video site for international content. So we have, you can look at the infographic and see that we have content from a lot of different countries. We started out with just K-dramas. Our very first show was Coffee Prince. I talked to one gentleman here, Tony, out there somewhere, who is actually a fan and has watched some K-dramas, which is pretty awesome. And but we also have, dramas from a lot of different countries. The funny thing is, most of our customer base, not all, but most of our customer base, because of the licensing deals we've signed, is in North and South America, which has the obvious effect you would expect on our traffic patterns. More about that later. Something else to consider, too, is that we're not actually just running that one site. We now are actually running a couple of sites for AMC. They were an early investor and partner, so we run a documentary site, and we have a quite terrifying horror site coming online for them. I think the therapy bills from people who have to QA it are going to be, crazy. But anyway, so this is what our, this is an actual, pulled from Graphite of our auto-scaling. So as you can see, we're all in on AWS, and we're all in on Docker. Everything in our request path is containerized. A lot of stuff not in our request path is also containerized. More on that later. But everything in our request path is containerized, and we auto-scale up and then down pretty aggressively, which means that we keep all of this completely stateless. Our data, our persistent stuff is in, like Redis for sessions, in Elasticache, again, we're in AWS, or in RDS, for the actual data layer. More analytic stuff in, like, Redshift. But in terms of the actual instances running the containers, they come, they go. We're very much in the cattle, not pets sort of variety there. And the actual video delivery stuff we handle as close to the edge as possible from our CDN layer. Currently, Akamai, we're adding in additional, we're going multi-CDN in the next quarter. So what are we serving in these containers that we've been doing for an inordinately long amount of time in, Docker years, which are, I don't know, are they like cat years, dog years? I don't know. So the obvious choice, of course, would be our Go microservices. Yay, those are a totally easy, great thing to put into your containers. Yeah, okay, and then you think, all right, greenfield, whatever. But we did actually take that. We put the giant, I say we, this is the I didn't work there yet we, put the existing monolithic Python Django app into containers as well. As you can imagine, those images are a lot larger. More on that later, too. And there's been a lot of really exciting talk here today about, CoreOS and etcd, and, I think somebody mentioned console and other things like that. And we're not doing any of that exciting stuff for service discovery because October 2013. That's something that I actually am very interested in adding, but right now we are using it's very simple, Nginx knows which ELB that, the upstream should go to, and routes accordingly. The auto-scaling groups know what they should come up with, and start accordingly. So, and then we do have, asynchronous stuff as well. The Celery instances come up and actually use the same Django image that the web servers use, only to, pull the workload out of SQS and run it, as opposed to, send it. One thing that every time I mention it to people, even last night to some Docker employees, people always say, huh? You're doing what? And so I thought I would highlight a little bit what we're doing with our registry needs. Docker Hub didn't have any private registry stuff when we started doing this, and we probably would have tried to, even if they had, we probably would have tried to avoid the not controlled by us single point of failure. But as it turned out, the controlled by us single point of failure wasn't really awesome either, because the chart that you saw earlier with the auto-scaling kind of says that we have a lot of instances can come up at the same time and all hit the registry and all want to pull their containers. And if you've ever done a whole bunch of those at the same time, you know that that can lead to problems. I think we would get maybe 20 or so scaling up at the same time before the single point of failure, which I think was actually, hilariously, the Jenkins server. I don't know, reasons, which is where the registry was running, would fall over. So instead of trying to scale that out, we actually went the direction of, why don't we just run the registry container literally everywhere? So all the host instances, it doesn't take that much in terms of resources. So all the host instances are actually running the registry container locally, and then doing all of their polls from there. And we're using the S3 as the storage backend for that. So instead of the single point of failure, we have the eventually consistent S3, which is actually fine. We haven't really had problems with that, and that's worked really well for us for scaling. A little bit of detail about how we're doing that. Obviously, you know that you have to give it an FQDN, so we are putting an alias into for 127.0.0.1 into DNS. That doesn't work anymore for boot to Docker because of what the changes in 1.3 for the host-only network. So for that one, we're actually putting the IP that we're using for the host-only network into Etsy hosts with tooling on people's locals. But in terms of what we're actually dropping in there, the astute among you will note the insecure registry. Sounds dire, honestly, and I talked just a little while ago to somebody who has recently joined Docker and is going to work on security, and I'm like, cool, awesome. Honestly, if people are in AWS, in our account, on our host instances, we probably have other things to worry about than whether or not talking to the registry on port 5000 locally is secure. We have other problems at that point. So we don't spend a lot of time worrying about that specifically. And then we run everything via Upstart. We haven't gotten into, etcd or I don't know, any of the init system wars. I get it. Systemd is both a floor wax and a dessert topping. Don't really care. I run FreeBSD at home, y'all, all right? But for, starting all of our containers, we use Upstart jobs. So we start the actual registry. We start the actual registry with an Upstart job. We pull the public registry image. We actually pull it from a DramaFever repo we set up in public on Docker Hub, specifically because one time, you know how you have that scar tissue because something happened that one time and then you're traumatized? And one time, the fine folks at Docker love you, but one time they pushed a version without bumping the version ID, but it was broken. And then we're trying to pull down the registry and it doesn't work anymore, and it was horrible. So now we just have a frozen one that is what we expect it to be. And we are actually configuring it with a config.yaml that we use the same one everywhere except our Jenkins server, because On our Jenkins server, we're actually allowing ourselves to push to this. As my boss, Tim, puts it, he doesn't want to do a Docker push, at 2 a.m. when he's drunk, and then everything terrible happens in production. I mean, that would be bad. So instead, we're just pushing from the Jenkins server instead of having any humans actually do Docker build, Docker push. I mean, people can Docker build all they want. They just don't have the credentials to Docker push it. But everywhere on all of the instances has credentials to read from that S3 bucket per the bucket policy. Jenkins, on the other hand, is the one that's actually doing the builds, the pushes. We do a weekly base build that basically just sets our baseline. This is the stuff, this is not the Go stuff, this is the Python Django stuff that takes absolutely freaking ever to build. All right, we build it a little bit faster by doing the slow stuff once a week. Then we do a dev master build with every merge. I think we actually cheat a little and have that one set to like every 2 minutes instead of like every GitHub commit. But every 2 minutes, we would kick off one of these builds, and it goes from that base that we build. So this is on our continuous integration. We're actually standing up, testing. We start a MySQL container. Again, we're using RDS in actual prod, but for Jenkins, we'll start a MySQL container, load all the fixtures we need to be able to effectively test the website, run all the tests against it. If we didn't break any of the tests, which, bonus, then take that candidate and actually tag it as dev. And then, hey, the devs can all pull that one and have the most current build from master if desired. They don't have to. I mean, and sometimes there's no reason to, but if you want it, it's much faster than the vagrant way that we were doing things. Like right before I started is when one of the first things I did was help all of the devs move to boot to Docker. Because, running Docker in production first and then moving it to development Docker 8 months later is totally a thing people do, right? I don't know, maybe. We did run into some hilarious problems, and I bet, raise your hand if you can tell by the highlighted thing exactly what the sadness is. Oh, yeah. So, Device Mapper is full of race conditions and sadness as a service. The fix for that is basically first whack at it with Nogginator. And those of you, how many of you were actually at the talk I gave at Lyft in January? Yeah, a few of you were at that. So some of you saw I haven't fixed this yet. And we got really, really, really sick of Leroy Jenkins. Yes, our Jenkins server is called Leroy Jenkins. I mean, isn't yours? We got really sick of it telling us in Slack that the build was broken all the time, especially because some of these builds are kind of slow. I think we have a 26-minute build with a whole bunch of tests, so no, that was bad. So that fixed it. Obviously, because, I don't know, rel or whatever, Device Mapper is pseudo the default, but mostly because Ubuntu had to be helpful and take AUFS out of the kernel because reasons? I don't know. Anyone who knows, tell me later why so that I don't have to be cranky about it. But putting it back in is obviously not hard. Yes, that is Chef. We are using Chef. More on that later. But apparently, the canonical answer from Docker employees is we should probably be using overlay. So probably we'll be switching to overlay at some point in the near to distant future. And then maybe not have file system sadness. But yeah, Device Mapper is actually still everywhere in our request path because, again, despite being the people who run Docker in production, because why not, if something works, we don't necessarily change it unless we need a new feature. So because we're not standing up and tearing down containers constantly on our production instances, we just stand the instance up, and it pulls its images, it starts its containers, and then it just keeps running them until it auto-scales down into oblivion. We didn't run into the Device Mapper problems there. On the Jenkins server, on the other hand, with dozens upon dozens of containers being started every hour, terrible. So yeah, don't use Device Mapper if you're changing out your containers a lot. But yeah, so we recently, in the last 5-6 months, actually started using Chef. And you're thinking, wait a minute, you have all the Docker. Why do you need configuration management? It actually ends up being a huge pain in the ass if you are using AWS and you're populating your user data with carefully hand-whittled bespoke artisanal files that are experiencing a lot of configuration drift one to another. It can end up being a huge pain because you have a whole bunch of auto-scaling groups that have sort of similar launch configs. Yeah, no, it's horrible. Don't do that. So being able to switch to using like just a Chef client run that just drops in exactly, like asserts what we think this autoscaling group is actually going to start and do and use, super helpful. And our upstarts, I mentioned the upstarts before, like this is an example of our Django one. You notice that there's a lot of like, oh, this one needs a -e of this, and it needs a -v of that. More on the log stuff in a little bit. But so going with a template for that, obviously, eRubus, I know, blech, but, and we're not evil, by the way, like we're not taking the Django settings.py and making the developers write eRubus for that. Like that would be cruel and unusual. I think the Geneva Convention has something to say about eRubus. But we are using it for like Upstart just because we end up being able to be a lot more consistent with what the user data ends up looking like that we're dropping. So that, again, just a little Chef stuff, throwing attributes of exactly what we want. And these slides will be posted online, so I'm just kind of going through the large blocks of text quickly, because you're not going to sit there and read attribute, : no one wants to do that, right? You're thinking, more pictures of cats. I don't have any pictures of cats in this doc, I'm sorry. But I do have some pictures of containers used in entertaining ways. But then we can use a lightweight resource provider and just like define exactly how we want our Docker run commands to look, which is pretty helpful. Adding Chef also allowed us to improve our AMI building process. So again, like, it's great that we have all this Docker, but we also need to run host instances. And I gotta tell you, when you hand whittle your AMIs, sometimes you end up doing things like forgetting to configure NX log. So then the log shipping that you thought was happening, not so much. And you look at Kibana and you're like, Kibana, why for you hate me? And no, I mean, there's a reason. It's because you didn't give it anything. And so like what this is actually doing, I can probably walk through it really quickly, is we're not actually using Chef like with knife upload cookbook and hopefully we checked it into GitHub, but maybe we didn't. And then we went on vacation and it was sadness. I mean, I've worked there. You've all worked there, right? But it's like things on the server aren't the things that are what? No. So we don't actually upload things to Chef server ourselves. We upload them to GitHub. We, PR them in. Somebody agrees with you that it should actually go out. GitHub gets it from, Jenkins gets it from GitHub once we've actually merged it to the, yes, we're really sure, not master, because we found out what happens when you accidentally merge to master and then everything just goes out. So we have an actual Jenkins branch that we merge to on purpose when we want to actually send Chef stuff out. That goes to Chef server. We do send it out to the live host instances, as well as using Packer to build new AMIs. So then we have like AMIs that are exactly consistent with what we actually want to do in production. So next time we have like a heart shock, shell bleed, sadness, or whatever, we don't have to suffer through, and now we have to replace our entire infrastructure now, which happened and was not fun. And a few things, if you decide to do something like this, make sure you choose your role and or recipe that you're going to configure your Packer builds with carefully. We ended up like separating out the exact things we wanted to be baked into the AMI and making them their own recipe, and then not running that in base all the time, right? Because there was one time that I was actually, wait, if anyone's playing the drinking game at home, Jesse is now going to get mentioned again in a talk. One time I like asked Jesse on Twitter, well, I think I just said, Team Docker friends, what gives? Get.docker.io was not answering me, and this is making our Chef runs take like 20 minutes. Because at the time, we foolishly had the, apt-get install Docker for us if we don't need it or if we do, like in every run. Why was I doing that? That was a terrible idea. So, of course, Jesse was very helpful and gave me the like, oh, okay, they're working on it. Yep, okay, they've got it fixed now. But meanwhile, I was like, excellent, we're going to peel this stuff out and only have it happen in the AMI builds, right? Because it's like, this isn't something that needs to happen constantly. And we also, and that's just more details of the kind of stuff that you would pass in if you're going to build AMIs that way. But the one thing that you might want to know about this, total digression from containers, but sort of relevant if you put this sort of thing in your workflow, is if you go to packer.io and you read what they say about the permissions you should give your Packer builder to your AWS account in production, it's like everything. give it everything, it'll work fine. Well, possibly, but some of the everything that it needs is the ability to terminate instances, which I don't know about you, but I would really prefer to have as few scripts and or people and or anything as possible have the ability, having the ability to terminate our instances, just because that would be kind of unhelpful if something were to go amiss. So this is the minimal set of permissions that it actually needs. I probably should just write a blog post about that or something, but it's in the slide deck. So limited set of permissions that Packer actually needs to work is that. All right, so what it looks like when we're actually deploying this stuff, for the running the actual deploys, it's currently Fabric, which is like 8 billion lines of Python. It uses Bodo. It's one step better than SSH and a for loop, but it's probably fine. But what we do is, if something has passed QA, we tag that image as staging. We throw it on the staging server, smoke test it. Assuming that passes, tag it as prod, then via one Fabric command, pull everything out of the load balancer, just restart upstart on it and put it back in. That's it. It's that simple. We are actually starting to experiment with more golden image-based stuff now that we have a really easy-to-use AMI factory. Golden image-based stuff, separate AMIs, because making separate AMIs is incredibly painful if you have more of a manual process. And also, more of a blue-green thing is what we're moving towards now. Done stuff with that in the past. It's fine, But this is actually, it's just dead simple. It's incredibly easy. So let's see. Right. Shipping disasters. So you have to have the picture of the terrible accidents at sea, because every talk about containers has to have that picture. But I kind of want to dispel a little bit of the around that, because honestly, the stuff is actually pretty solid. It's actually pretty stable. Docker's worked really well for us. I mean, because I don't know about you, and I know I've made this joke before, but I'm going to make it again. All right, raise your hand if you make your important technology decisions by running a Markov chain generator against the front page of Hacker News. Anyone? Anyone? Yeah, no. We didn't pick Docker because it was hilarious or awesome or fun or cool. We picked it because it actually is solid and works. And it's it works really well for us. So. Yeah, okay, we have actually had some hilarious, weird failure cases, but if you're using the stuff enough, you're always going to run into those, right? Something okay, we're using S3 to back our registry. S3 really cares about your clock sync. So if your laptop goes to sleep, I ran caffeinate. I don't think my laptop's going to go to sleep. Plus, I'm going through these slides pretty fast. But if your laptop goes to sleep, the boot to Docker VM, the VM running for VirtualBox or whatever, may very well decide to suspend time. We had that happen a lot. So then time is suspended, time starts back up. S3 believes that you have not even remotely the sort of time that you should have, and your registry no longer works. Well, guess what? All right, we can throw this hackish command into every wrapper script ever and fix that. I don't even care. It's that's not even Docker's fault. That's just, VirtualBox and Macs and suspending. We did end up, and you're looking at these and you're thinking, wow, YOLO. But again, the defaults are, it's not going to remove anything that's running. So it's fine. It's probably fine. Jesse's looking at me oh my God, YOLO. But yeah, so on our persistent, and this, and again, this isn't even in production. This is on dev instances that run for a long time. Yeah, they can get really cluttered. Whatever, just clean them up. It's probably fine. We had this hilarious problem with this flate error that was mysterious and weird and kind of horrible. And the problem would be, it would manifest itself in that the registry would just not work at all on instances as they scaled up. If the registry didn't work, we couldn't pull down the current image that was supposed to launch the container that would make that instance become healthy and go into the load balancer. So all of our CloudWatch alarms would start going off saying, you have too many unhealthy instances. And I'd be log in, yes, we do. We have way too many unhealthy instances. What the hell? And okay, so what the slide used to say was, when the registry rewrite happens, hey, guess what? Thank you. Apparently, it actually landed yesterday. So strangely enough, what with being at container camp and everything, I have not actually upgraded yet. I know. I mean, you're all on registry 2.0 by now, right? Yeah, half the room at least. Yeah, no one. But except Jesse, maybe. But yeah, we're definitely going to not have that flate problem anymore. But until then, whatever. There's perfectly good workarounds. I found many, many workarounds for any sort of weird stuff, like in the GitHub issues in the Docker project, basically. All right, on the isolation thing. So there's so many exciting, fancy ways to manage your logging in your containers if everything has to be isolated and nothing can ever talk to your host instance and whatever. Like, we don't really care about any of that because, I mean, while we do run sites that are for a customer, like, we don't have, like, customer data on the same, even on the same stack. It uses the same code base, but it's not on the same stack as any of, like, the other stuff, and it just doesn't matter to us. So, like, we just ship the logs out to the host instance and then just send them to nxlog with, you know, a normal nxlog sort of config. And it's like, again, is that the most, like, I don't know, the Docker orthodoxy way to do things? I don't know. I don't care. I mean, probably not. But again, this is like pragmatic Docker. This isn't like the ideal, if there's an ideal. I don't know. And also, when I started this job, they had just finished like a let's containerize absolutely everything we have. I mean, we didn't containerize CloudWatch. Obviously, we didn't containerize the things we don't run. But this is what our monitoring, logging, whatever stuff looks like. And all of the things we do run, all of these are actually in containers, which, what? So honestly, I don't think Graphite performs its best in a container. I don't. I mean, it's I/O intensive, and it's like kind of kludgy and terrible to have. I think we have Bucky or something. I don't even know why. Like running absolutely it's just like this. Actually, the Docker command to start that is like this shell script that starts Bucky with like, you know, Carbon and, you know, like Graphite Web and everything. And it's like, no, this is terrible. We shouldn't be doing this. So that's kind of my like, yes, containerizing everything is great, except where it's not. Jessie will have other things to say on that subject. I'm not going to spoil you for her exciting talk, but don't leave early, because you need to hear that. But we definitely have found that there are things that are more helpful in containers, a lot of things, and some things that are probably less helpful in containers. And it's probably fine if you don't actually containerize all the things. One other thing to consider that's just kind of a fun place to stop, I think, is that we actually have found that because we're building all of our images on Jenkins, and we have some images that can run with almost no dependencies, like if it's, you know, if it's our Android packages, or if it's in terms of like the build, or in terms of running in production, if it's some of our Go microservices. I mean, if you don't care about libc, I mean, I don't know, do you care about libc? But like, if you don't care about libc with your Go stuff, yes, Matt. If you don't care about libc with your Go stuff, you have a lot of flexibility as to how you can actually do this, right? So what we end up doing for some of the Go things is we use a builder container to build the binary, and then we actually go from scratch and mount in, like, and copy in, like, our Docker file to run the image, like to build the image that we're going to run is from scratch. I probably should put that Docker file in the stack, but it's like from scratch, and then copy in like the actual Go binary, and maybe like, you know, make a directory for logs, and that's pretty much it. So while our monolithic Django stuff is like, you know, a gig or so, the MySQL thing, that's just for dev. Again, that's like the testing fixture stuff that I was mentioning. But yeah, our www image is like a gig, whereas our smallest Go microservice image is literally, this is not made up, this is real, 10 meg. So it's actually pretty nice because, again, with the auto scaling that I mentioned, if an instance scales up and it goes to pull the image it needs from S3, that takes a non-zero amount of time, especially if it's pulling a gig, especially if S3 is doing one of those network glitchy things that it sometimes does, which, you know, whatever. It's been slightly better since we moved everything into VPC, crossing fingers, toes. But yeah, so that's actually pretty exciting. Yeah, so I have no idea if I'm over or under time, but I just wanted to kind of put the pitch out there that DramaFever.com, we're pretty cool. We're hiring. We're super remote friendly. The headquarters is in New York. The main tech team is in Philly. I live in Minneapolis, and you know, sometimes just work from the airplane. So if you like that sort of thing and everything that I described sounds kind of fun and cool, then you should at least go check out our careers page. Yeah. So do I have time for questions? Am I over, under time? I have no idea. Thank you. All right. Thank you so much.